Welcome back, students. This is the session 1 from the playlist of JEE Advanced Part 2, and this is the session number 1. And in this session, I will be taking up the questions starting from the chapter number 1 of from the syllabus of class 12 board exams. In this playlist, I will be taking up the questions which has been asked in the JEE Advanced examinations in the previous year. So I have taken this question for this session, and this question was asked in the this IIT JEE Advanced examination, I think in 2015. So the question here is, the charges Q, 2Q and 4Q are uniformly distributed in three dielectric solid spheres of radius r by 2, r and 2r respectively, as shown in these figures. So these three figures was given along with this question. If the magnitude of the electric field at a point P at a distance r from the center of the sphere, these are 3 points P, which is at a distance of r from the center of these three dielectric solid spheres. If the magnitude of the electric field at the point P at a distance of r from the center of these solid spheres, that is 1, 2 and 3. So this is the sphere number 1, this is the sphere number 2 and this is the sphere number 3, are E1, E2 and E3 respectively. Then we have to find the correct alternative out of these four, and these four alternatives are that E1 is greater than E2 and this E2 is greater than E3, then E3 is greater than E2 and E2 is greater than E1, and then E2 is greater than E1 and E1 is greater than E3, and the fourth option is that E3 is greater than E1 and E1 is greater than E2. So there are four options here and we have to find the correct one. So now, before solving this question, I have written one small note on this board in order to save the time. So see, whenever a dielectric is placed in an external field, whenever a dielectric is placed in an external field, the external field induces a dipole moment by rearranging the molecules of the dielectric. So here I have already written here that when a dielectric is placed in an external field, the dipole moment is induced in the dielectric by the rearrangement of dielectric molecules. Now the collective effort of all the dipole moments produces a net electric field which opposes the external field. However, the magnitude of the induced electric field in the dielectric is less than the magnitude of the external field, and as a result of it, the electric field lines, they pass through the dielectric. So here I have already written that same thing here. That is, the magnitude of the induced electric field is less than the external field, and therefore the electric field of reduced intensity passes through the dielectric. So in this case, because this is this sphere is made up of a dielectric medium, therefore in this case these electric field lines of reduced intensity will pass through these dielectrics, through this dielectric sphere. Now there are three spheres here, and the radius of the first one is r by 2, the radius of the second one is r, and the radius of the third one is 2r. So these are the 3 points here. This in the case of the first, this point P is outside this dielectric sphere. In the second case, this point P is on the surface of this dielectric sphere, and this point P, that is in the third this dielectric sphere, this point lies within the solid sphere. So now in the case of a conductor, the conductor has got free charge carriers, that is it has got the electrons and it has got the positive ions. Now, so in the presence of the electric field, in the presence of the external electric field, these free charge carriers, they rearrange themselves in such a way that the induced electric field inside the conductor opposes the external field, and in this case the induced electric field completely cancel out the external field. So as a result of it, the electric field lines are not able to cross the conductor. So this was a brief explanation, and which I wanted to give or explain it to you before proceeding with this question. Now, in this question, I will be using the Gauss law in order to get the answer of it. So here I will be using the Gauss law, that is I will be constructing here the Gaussian surface. Now this is the Gaussian surface which I am denoting with these dotted lines. Okay, now here in this case the Gaussian surface will be like this, and in this case, that is in the sphere 2, the Gaussian surface will be the surface of the sphere itself. Now, as per the Gauss law, the net electric flux from a closed surface is directly proportional to the charge which is enclosed within the surface, and it is given by EDS. This is equal to Q divided by epsilon naught, where epsilon naught is the permittivity of the free space. Now, in this case, we have got 3 dielectric solid spheres in which the charge is uniformly distributed within the sphere. It is a solid means we have been given 3 dielectric solid spheres in which the charge is uniformly distributed. So in the case of this dielectric medium, the Gauss law is given by EDS K epsilon naught. Here, see, here K is what? K is the dielectric constant of this dielectric medium, and epsilon naught is the permittivity of the free space. We also know that there are 2 formulas. That is, the permittivity of a medium is given by is equal to the permittivity of the free space multiplied by this relative permittivity, and there is one more formula which I think every one of you must be knowing, that is the permittivity of a medium is equal to K times epsilon naught. So in the case of a dielectric, the Gauss law is given as EDS, that is equal to Q divided by K epsilon naught, where K is the dielectric constant of that dielectric, you can say this medium. So here I will be using this formula, and using this formula I will be calculating the value of this E1, E2 and E3. Okay, so now this will be equal to, this is given by, so in the case of a dielectric, the Gauss law is given by this equation. Now in the first case we have been given that the the magnitude of the electric field is E1. So E1. Now ds means the total surface area of this Gaussian surface is 4 pi r square, because the surface area of a sphere is equal to 4 pi r square, and here this point P is at a distance of r from the center of the sphere, and this will be equal to Q. Q is a charge which is enclosed in this dielectric sphere, and it is uniformly distributed, and this is equal to K epsilon naught. So from here I will be getting the value of E1, which is equal to Q divided by K epsilon naught into 4 pi r square. So this is the first equation which I have got. For this sphere, I will be using the same formula, and that is this will be equal to E2. E2 is the intensity of electric field at the point P, and the total surface area of this Gaussian surface will be equal to 4 pi r square, and here the charge is 2q divided by K epsilon naught. So here E2 will be equal to, it will be equal to 2 times Q divided by K epsilon naught into 4 pi r square, and this is equal to, see, this Q divided by K epsilon naught 4 pi r square is equal to E1. So E2 is equal to 2 times of E1. Okay, so here I am getting that E2 is equal to 2 times of E1, and E1 is equal to Q divided by K epsilon naught 4 pi r square. Now we have to find the value of E3. Now in this case, this point P is lying within the sphere, and here the charge is uniformly distributed, and the charge on this third sphere is 4q. Now, since the charge is uniformly distributed within the sphere here, so we have, now this is the Gaussian surface which I have denoted by a dotted line. So here we have to find, see, as per the Gauss law, the total electric flux which is passing through a closed surface is directly proportional to the total amount of charge which is enclosed within that Gaussian surface. So here we have to find the total charge which is enclosed within this Gaussian surface. So how we will be able to calculate it now? See, this 4q charge is distributed in a volume of 4 by 3 pi. Here the radius is given by 2r. So this is the radius. So this is the total volume of the sphere, and this 4q charge is distributed in this volume uniformly. So I have to find now the volume of this Gaussian surface is volume of the Gaussian surface, or you can say the volume of Gaussian surface is equal to 4 by 3 pi r cube. Okay, so because this point P is at a distance of r from the center, so the volume of the Gaussian surface is equal to 4 by 3 pi r cube. So the charge enclosed within the Gaussian surface this will be equal to 4 by 3 pi r cube divided by 4 by 3 pi. This is, that is 4 by 3 pi r cube divided by 4 by 3 pi 2r whole cube, which is equal to 8 r cube into 4 cube, because this is the total amount of charge which is present in the volume of that sphere. So this is equal to 4 cube. So if this will get cancelled out, and this 4 will get cancelled by 2. So finally, and this r cube will get cancelled out. So finally I am left with q by 2. So the charge enclosed within the Gaussian surface is equal to q by 2. So the value of E3 will be, by using the Gauss law, I will be getting this equation, that is E3 ds. Now the total surface area of this Gaussian surface is equal to 4. This will be equal to as per the Gauss law, this E3 dot ds will be equal to, now the charge is equal to q by 2, and it will be k epsilon naught, and here it implies that E3 ds, that is the total surface area of this Gaussian surface, is equal to 4 pi r square, and this is equal to q divided by 2k epsilon naught. And so from here, E3 is equal to q. So what I will be doing is, I will be just writing this equation in such a way that this q divided by k epsilon naught 4 pi r square will be taken as one term. So k epsilon naught 4 pi r square, k epsilon naught 4 pi r square, k epsilon naught, and this is into 2. Okay. Now this q divided by k epsilon naught 4 pi r square is E1, as E1 is equal to k divided by k epsilon naught 4 pi r square. So this E3 will be equal to E1 divided by 2. So now I have got three relations. That is, first thing is that E2 is equal to 2 times of E1. I got two relations now, not three. That is, E2 is equal to 2 times of E1, and E3 is equal to E1 divided by 2. Okay. So here, from these two relations, we can find that, see here, E2 is greater than E1. E2 is greater than E1, first thing. And from here you can see that E1 is, E3 is equal to E1 divided by 2. So E3 is less than E1. Okay, now from these two relations, here E2 is greater than E1 and E1 is greater than E3. So the finally I am getting is that E2 is greater than E1 and E1 is greater than E3. So this is the relation which I have from this solution, and I have got four options here. So E2 is greater than E1. So here E2 is greater than E1 and E1 is greater than E3. So the correct option is C. So in this question, the most important thing which we have to remember was that the Gaussian law, in the case of a this dielectric medium, is given by the formula that is given by the formula that is EDS is equal to Q divided by K epsilon naught. In the case of the Gauss law, in the case of a free space, that is given by epsilon, the summation EDS is equal to Q divided by epsilon naught. So these are the two important formulas which you have to remember while solving this question. And so the answer here is that E2 is greater than E1 and E1 is greater than E3, and the correct option is 3. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question which was asked in this advanced examination in the previous years. So till then, have a nice day. Bye.